All right, good afternoon and good morning to some of you. Let's go ahead and get this webinar started. Hello and welcome to today's edition to NLPA's US Inspector Training and Webinar Series. Today's webinar will be on spill bucket and containment sump testing and repair. My name is Nick Bissonette and I will be moderating today's session. Drew Youngs from NLPA will also be providing assistance in today's webinar. Before we get started, I'd like to go over a few items so you know how to participate in today's event. All attendees are in listen-only mode. We've taken a screenshot of an example of the attendees interface. You should see something that looks like this on your computer desktop at the upper right-hand corner. You're listening by using your computer's speaker system by default. If you would prefer to join over the phone, then just select the telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your question into the questions pane of the control panel. You may send your questions in at any time during this presentation. We will we will have a short Q&A session after each presenter, as well as a longer Q&A session at the end of the webinar as time allows. Please address all questions to a specific presenter by typing their name in the question box. In the handout section of the GoToWebinar panel, you will find a copy of all the slides for today's presentation. After the completion of today's webinar, you will be asked to fill out a brief survey to quickly respond and let NLPA know how your experience was today. An electronic certificate of attendance will be emailed to the address used to register. Please note that today's presentation has not been evaluated to meet any continuing education requirements. Now, with that, I'd like to introduce our four speakers. First, we have Russ Brosick. Russ Brosick is a professional engineer with the New York State Department of Environmental Conservation and is currently on assignment with EPA OUST. Russ has been with the Tanks program for over 34 years. Next, we have Ed Kabinski. Ed Kabinski is the Director of Regulatory Affairs, Training, and Certification with over 26 years of experience working for Cromco, a large UST testing service provider headquartered in Plymouth Meeting, Pennsylvania, servicing over half of the US with their compliance testing services. He also serves as chairman of PEI's RP 1200 committee, is a member of PEI's Service Technician Training Committee, and a member of the NLPA KWA Standard 823 Committee for sump repairs. Next, we have Roland Riegel. Roland is in his 35th year at UL, primarily conducting safety evaluations for traditional and alternative energy generation and storage delivery systems. Also, this is his 18th year as principal engineer for flammable liquids containment products, UST to shear valve, to lead development and coordination of UL standards and codes, in addition to providing technical direction and oversight for the associated UL certification services. Roland also participates in as a technical committee member for NFPA 30, 30A, 31, and ASTM F15.10 committees. Last, we have Tony Reek. Tony Reek began work in the petroleum industry since 1978. He was executive director of NLPA from 1988 through 1996. He is currently a technical standard advisor to the association. He formed his own company, TR Consulting, in 1991 and is chairperson of the NLPA KWA 823 Standard Committee. Now just going over the agenda for today, we'll be starting with Russ leading us through a policy background for sump testing, followed by Ed touching on some state licensing requirements, as well as PEI RP 1200. Next, Roland will give an overview of UL 2447 standard. Lastly, Tony Reek will go over NLPA KWA standard. With that, we will transition to our first speaker, Russ Brosick, and I will give over controls to Russ. And you should be able to control it now, Russ.
Very good. Thanks, Nick and NLPA for putting this together. Thanks, everyone, for joining us today. Look forward to the time we have together, questions and stuff coming in. Should be a very interesting time. The goal of my portion of the presentation really is to talk about the regulatory framework. What has to be tested, how can it be tested, run through some common scenarios, questions that we've been getting in that hopefully will address some of the questions you guys have. Okay. There we go. So the regulatory requirement, simply put, spill prevention equipment, containment sumps used for interstitial monitoring have to prevent releases by being liquid tight, being shown by either being double wall, the integrity of both walls being monitored, or being tested at least once every 3 years. That's just a straightforward regulatory requirement. So let's break it down. Spill buckets. What has to be tested? Well, spill buckets at fill ports where the delivery hose is disconnected. Well, what doesn't have to be tested then? Spill buckets, if you have them at a vapor recovery port underneath the EPA regulations, would not be a spot where delivery hose is disconnected. Therefore, that's not required. Double wall spill buckets don't have to be tested if the integrity of both walls is periodically monitored, which means every 30 days, or if your deliveries are less frequent, before each delivery. Pretty straightforward. Containment sumps. Containment sumps have to be tested if they're used for interstitial monitoring of piping. So what doesn't have to be tested is obvious, not used for interstitial monitoring, but there's a lot of nuances to this one. So owners and operators have been installing double wall piping systems for a long time before there was a requirement that they had to have it or that they were required to use interstitial monitoring. So just because someone has interstitial monitoring capability doesn't mean that they automatically have to test the containment sumps. Another common one is under dispenser containment. They have to be done if they're used for interstitial monitoring, but not all of them are, because there are situations where somebody has replaced a dispenser, put in a new dispenser, and they are required to put in the under dispenser containment even if they're not using interstitial monitoring. So there's going to be some situations out there where UDCs are in place and containment sumps on the top of the tank that are not going to be required to be tested. Of course, the other one would be the double wall containment sumps, where the integrity of both walls is monitored, in this case at least annually. So just a couple of common scenarios. This is a figure out of PEI RP 100. This owner operator has a double wall system, and they're either required or they're choosing to have their release detection method be interstitial monitoring. So with the piping sloped back to the tank top sump, that is the monitoring point for the interstitial monitoring. However, one of the things that is common out there is the piping system and the UDC is single wall as well. And since they're doing interstitial monitoring, that piping also has to be monitored. And so the interstitial, the secondary containment for that is the UDC. And since they are using that as a secondary containment and a monitoring point, the UDC also has to be tested. Okay, whoops, went too far. So just a couple other common scenarios that are out there, some things that manufacturers are continuing to make good progress in bringing new things to market. Double wall piping systems, flex pipe, where they run it from dispenser to dispenser. They try to make sure that that interstitial space is connected all the way back to the tank top. But you'll notice here the red circle says that coupling has a jumper cable around it, connecting the one interstitial space to another, and that therefore means that coupling is single wall. And when they're doing the interstitial monitoring, therefore, this UDC is the secondary containment for the pipe, has to be monitored, and therefore is indeed have to be tested if they're using interstitial monitoring. Last common scenario out there, new one from OPW, the FlexWorks system. Again, people are looking to minimize single wall fittings, coming up with new designs. But when you look under the dispenser, those couplings that are underneath there are also single wall. And so this is another scenario where if they're doing interstitial monitoring, they have to monitor in the UDC, and then they also therefore have to do the testing of the UDC. So that's the basics of what has to be tested. Let's talk a little bit about the how. Again, the regulatory language, testing of spill buckets and containment sumps have to be done in accordance with requirements by the manufacturer, code of practice, or requirements determined by the implementing agency to be no less protective. All right, so let's tear that down a little bit. Testing of spill buckets. So looking at the three requirements developed by manufacturer. So if we're looking at single wall spill buckets, I don't know of a manufacturer that's come out with testing procedures on what they expect, but that would be a possibility. Code of practice is the PEI RP 1200, and requirements by implementing agencies. Well, EPA has not come out with anything that would be an alternative. So really the main thing for spill buckets would be the RP 1200 standard for getting that done. Testing of containment sumps. Well, this one's a little more nuanced and complicated, so let's tear it down a little bit further. Requirements developed by the manufacturer. As far as I know, there's not a single wall containment sump manufacturer that's come out with testing procedures for what they're looking at. There is a new system coming on the market. I don't think it's on the market yet. That is a hybrid system, a single wall top of the tank sump, but it's double bottom. And that double bottom is going to come with manufacturer's instructions on how to do the test. So it would look like something like this. So the bottom part of the sump is going to have the double wall with the ability to do some monitoring in there. And they're going to come up with some procedures on how to do the test. It wouldn't be monitored continuously, so they would have to do something on a periodic basis to make sure that both walls are tight. All right, let's skip for a moment the code of practice and talk about requirements determined by the implementing agency to be no less protective. EPA has decided to accept low liquid level testing, as well as some alternative test procedures that are meeting a criteria. Point here is this is what EPA as the implementing agency has determined to be no less protective. States are going to need to look at these and determine if they want to do the same thing or something different. I know, for example, the low liquid level testing, several states have come up with their own procedures, and that is fine. Those are things to take a look at. So, low liquid level testing, don't really need to go into any real detail. That's been talked about before. Conditions and procedures are available on the EPA website. Really just a couple of quick things for you to note that the conditions and procedures set up by EPA are slightly different than those that are set up by RP 1200. Point being that owners and operators that are going to do low liquid level testing have to choose one or the other. Unless the state is going to come up with saying some hybrid is acceptable, they need to either fully comply with what EPA says, or they need to fully comply with RP 1200. There are some nuanced differences, and just need to walk through and make sure that they're not choosing portions of each of those. Recently, EPA determined that there are alternative test procedures on the market and that there needed to be a criteria by which EPA would say they're going to be acceptable. So we came up with these. There's really 3 criteria. One, the obvious, the sump has to be tested for liquid tightness using vacuum pressure liquid. Pretty straightforward out of the regs. We also then came along and said, let's use the release detection criteria. Let's say that it needs to be able to detect a leak of 0.1 gallons per hour, probability detection of 95%, less than 5% probability of false alarm. Just like release detection, those need to be demonstrated that they can meet that criteria, being evaluated by independent party using an applicable test procedure, the protocol that EPA has looked at, and that the release detection technology being evaluated is appropriate for that protocol. And just like the release detection aspects, the National Work Group on Leak Detection Evaluation has agreed to be looking at those. And so they will be getting those reports in, doing the review, making sure the criteria is met. And those that do meet the criteria will be listed on the New Glide website underneath secondary and spill containment test methods. Gave you the link here. Here's a quick screenshot of it. You'll notice that there's currently 4 different manufacturers that have gone through the process and have gotten their systems listed here. All right, let's go back to testing a containment sumps using a code of practice. Code of practice meeting regulatory requirements talked about within the regs, and everybody understands is the RP 1200. That is something that Ed Kaminsky will be talking about in just a couple minutes. But I also want to make sure that everybody got the message that there's another code of practice out there that we've looked at, and it does not meet the regulatory requirements. ASTM came out recently with a standard practice for performing a liquid test by visual examination. Since it does not use vacuum pressure liquid in order to accomplish the test, EPA determined that it did not meet the regulatory requirement. Record keeping, certainly things that all of the inspectors should be aware that when they get to do the inspection, there has to be records. We try to make it simple, so both PEI RP 1200 as well as the EPA low liquid level test have forms to document it. If somebody is using the double wall and monitoring the system periodically, they need to make sure that they have documentation that that monitoring is being done. After Ed Kaminsky comes and talks about the testing procedures under our 1200, we're going to be talking about a couple other things. So sump repair. Repairs to sumps and repairs to US systems in general have to be properly conducted in accordance with a code of practice. So there hasn't been a good code of practice out there at this point. And so Tony Reek is going to come and talk about the development process and where we are in getting a new standard. The other piece is no matter what's going on with the US system and the repairs to it, they need to be compatible. Now, generally compatible, but in particular, if they're storing more than E10 or B20, there has to be records that demonstrate that not just the sump, but the repair is also compatible with the substance stored. Roland's going to be coming to talk about UL's efforts along those lines. And with that, that paints the framework of what we're dealing with, what and how, and some of the common scenarios there. Got a couple of minutes to take questions now, and then we can move on.
Great, thanks so much, Russ. Let us look through some of these questions that we have. Let's see. First we have, if the interstice of the double-walled sump is a dry interstice, can both walls be considered monitored with the sensor, or will the every 3-year test be required?
So the dry sensor situation is one that EPA does not consider to be monitoring the integrity of both walls of the sump. What we would be looking for is for the that interstice be looked at using pressure liquid vacuum. So from EPA's perspective, that would be what would be required. States do have some flexibility if you look at the 281 requirements on what states can do different than EPA. There is some room in there to take a look at that, but that is how EPA would approach it.
Great. And just a quick reminder to please address any questions. We are getting multiple questions, so just be sure definitely for this section, having Russ's name be a part of it. All right, so thank you. Next we have Russ. What is an example of a pressure test for a spill bucket or a sump?
An example of a pressure test. Well, that is a good one, right? So if we take a look at PEI RP 1200, right now they have the hydrostatic and they have the vacuum test. There's not a lot of demonstration yet of pressure testing, but that is something that the regulations made an allowance for. So it's in anticipation more than anything else.
Great. Someone wrote in, I think this was kind of just answered, but do manufacturers require testing of spill buckets and containment sumps at the time of installation? If not, is the expectation that they are tested at installation?
Great question. So the standard in code of practice for installing these, most people use RP 100, and underneath that there is a requirement that they be tested at the time of installation. EPA talks about that a little bit within the preamble of the regs and talk about that it occurs at time of installation and then every 3 years thereafter if they're single wall and they're having to do the testing.
Next, we have Russ. Are the exposed pipings couplings housed with the UDC part of the underground piping run all throughout an actual underground piping run does not open nor drain into the UDC? I wasn't sure if that came out clear. Did you were you able to understand that?
I think so. So let me take a shot at it, and then if there's some follow-up, we'll do that.
Okay.
So one of the things that people have to understand is the definition of piping. And the piping includes all of the connections and couplings all the way up to basically the shear plane of the shear valve underneath the dispenser. So if there's any of that is single wall, that is therefore, if somebody's installing a new one, they're using the interstitial monitoring, needs to be secondarily contained. And the UDC, therefore, since there's those single wall couplings in there, become the de facto secondary containment for the piping, and therefore has to be monitored for release detection and would be tested underneath the UDC testing requirements.
So with that, I think we will have to move on to our next speaker. Thank you again, Russ, for taking the time to answer those questions. And with that, we can start to dive into Ed Kabinski, his presentation, and I will hand over controls now. All right, Ed, you should be able to go ahead.
All right, thank you. Good afternoon, everybody on the East Coast, and good morning to everybody West Coast. A couple of the goals of my presentation are to explain some of the underground storage tank testing licensing requirements in several of the states where Cromco does work. primarily the East Coast. And I also give a shout out to Doug Hansen from Utah for researching some of the West Coast states on their licensing requirements that I'm not terribly familiar with. So that part of the presentation is not going to be inclusive of all states. Otherwise, I'd need a lot more time to go through licensing requirements. But I'm going to touch on several states, and as you'll see during my presentation, I think you'll get the feel for, I'm a big proponent of continuing education, licensing for technicians that are doing this type of work, just because it develops a good relationship between the individuals doing the testing activities and the regulatory agencies. They get to know each other. A lot of times when continuing education occurs, it's face-to-face interaction, and I think that that's definitely a positive for our industry. From the licensing requirements, then I'll get into a little bit about RP 1200. I'll briefly go through the spill bucket testing. Once again, I'll get into the new low-level testing that RP 1200 2019 version came out, and then I'll touch on sump repairs, and then we'll pass it over to Roland. So with that, I'm going to start out with my home state, Pennsylvania, for licensing. We'll start out with Pennsylvania because it's a little complicated to understand the licensing requirements. We have about 15 different categories of above ground and underground certification to do work. I'm going to obviously focus on the underground categories, but basically I'm going to go through several states. So in Pennsylvania, we have to demonstrate current and valid manufacturer's certification in order to just apply to to become a tester. No cost to apply. Once your application has been approved and you're eligible to take the exams, an individual must take and pass 2 exams to become certified. One exam is called the administrative exam, and that's on the DEP rules and regulations. And then the second exam that needs to be taken is a technical exam in the category that you're applying for. Certification lasts for 3 years in PA. Obviously, people doing testing have to maintain their manufacturer's certification over the course of their certification period. You also have to attend continuing education once every 3 years. There is a 4-hour DEP administrative training that's face-to-face, and that covers all the rules and regulations. And then you also have to attend a category-specific approved training class as well. So I'm going to get in my next slide, I'm going to get into the different certification categories, UTT, UMX, UMI, and IUM, and I'll explain those. And then you have to reapply every 3 years. No cost for reapplying. There's no cost to apply for exams, but there is a nominal fee to take the exams. So moving on to the categories in Pennsylvania, we have IUM. IUM is the Underground Storage Tank Compliance Inspector category. And in regards to all the new equipment testing that we're talking about, spill buckets, containment sumps, ATG certifications, and overfill testing, the IUM inspector can perform all the new testing except for overfill equipment testing, unless they have different, if they have additional categories of certification, UMX or UMI, then they would be able to do it. But IUM alone can do everything except perform overfill verifications. The UTT category is the underground tank and line tightness testing category. These individuals can perform all the new testing as well, except for the overfill testing. And that category is also required to perform any tightness testing activities for tanks and lines. UMX is our installer category. The UMX certification allows that individual to perform all the new testing, spill buckets, sumps, overfill, and ATG certifications, but they cannot do tank and line tightness testing unless they have the additional category of UTT certification. And last, the UMI category. This is a new category that DEP added with the last regulation change, and that is the underground tank minor modifications category. These individuals can perform all the new testing, spill bucket sumps, overfill, ATG certifications, but unless they have UTT certification, they can't do tank and line tightness testing. It's kind of like I like to call it a UMX junior category. They can't install tanks, they can't perform spill bucket replacements when you have to excavate, but this category of individual can perform repairs as long as it doesn't require excavation. So they can do sump repairs, they can do overfill equipment replacements, replacing overfill drop tubes, removing ball floats, etc., as long as it doesn't require excavation. All right, moving on to another state where we do work, Rhode Island. In Rhode Island, we have to apply for a license as a tester on an annual basis. Both the company and the individual must apply. There's no exam, no continuing education. We pay a fee per individual and company on an annual basis. And along with that application, we document our equipment manufacturer certification, and we also have to document liability insurance. State of Maine, you have to apply for installer or inspector certification for certification. A fee applies to that. You have to take a pretty rigorous exam. There's a fee for the exam. Your certification is valid for a 2-year period. You have to take 8 hours of board approved continuing education. One thing Maine does is that Maine DEP hosts an annual class, an 8-hour course for installers and inspectors, which is very well attended, but that's only approved for 4 hours of CE. So you can do that 1 year and then do it again the second year, and that would get you your 8 hours. DEP also has approved some online training courses as well for continuing education. You have to reapply, pay a fee. All underground storage tank testing in Maine, whether it's tightness testing or spill buckets or sumps, it has to be conducted by or overseen by a certified tank installer or inspector. Just an FYI. And yeah, my note there, I participate quite regularly with Maine DEP's continuing ed, and I find it very useful. Next state, New Jersey, you have to take and pass the ICC U3 tank testing exam to become a tester there. There's a fee for that. You only have to take the exam once. You don't have to take it every 2 years like in some other states. You have to apply and document experience doing the testing and your manufacturer certification. There's a fee for that. The certification is good for every 3 years, and you have to take an 8-hour NJDEP approved continuing education course in order to renew by continuing education. There's also a renewal fee where you'll get invoiced every 3 years to renew your license. And then New Jersey has a number of certification categories as well. Installers as well as testers are able to perform all the new testing we're talking about. West Virginia, we need to apply, take an exam to be either Class C for tank and line tightness testing, or Class F is a new certification category for repair technicians. So if we're replacing spill buckets that don't require excavation, or you're replacing overfill equipment, you would need the Class F certification. Certification is valid for 3 years. They just changed that with the new rule. It used to be a 2-year certification, now it's a 3 years. And you need to renew by either taking the exam, or you can take 16 hours of continuing education that has been approved by West Virginia DEP. 8 hours can be in safety, and then the other 8 hours is typically category specific. Next state I'll talk about is Florida. Florida, we have licensing with the Department of Business and Professional Regulation. There's a fee required for that, pretty intense application that requires a personal credit check as well as fingerprinting in order to be licensed. We do renew by taking 16 hours of continuing education, can be face-to-face class or online. done every 2 years. The issue that I have with this continuing education in Florida is it doesn't have anything to do with UST work. It's very general about being a contractor, talks about wind mitigation and a lot of things that have absolutely nothing to do with underground storage tank work. So if it's one thing I'd like to see, you know, if we're taking the time to do continuing education, I would certainly like to see it applicable to the work being done. And then we renew every 2 years. Couple of the West Coast states, thanks to Doug, Wyoming has certification requirements. ICC has a Wyoming specific W5 tightness tester certification needed for initial licensing, and you need to renew that by taking the exam every 5 years. And you need to apply for a license. Montana, testers have to be licensed there. Licensees have to get 16 hours of continuing education every 3 years and attend at least one licensee training class every 3 years. Glad to see, you know, there's a lot of emphasis on continuing education in Montana, even though I've never participated in it. And licensees must obtain a permit for repairs. Colorado, another good thing I like to see, PEI has a certification for service technician training. I was involved in the development of that training course, and it seems like Colorado has a qualified service technician requirement where you need to take that training and pass the PEI test in order to get licensed, and that certification is good for 2 years. Utah, Doug told me, testers are required to be certified. Similar to Pennsylvania, you're taking and need to pass a state administered exam. Certification is good for 2 years, and the only way to renew certification is by taking the exam every 2 years. One note that Doug gave us as well is that owners can perform hydrostatic testing as long as they follow RP 1200 and take photos. That's pretty interesting. And then, you know, there's a number of states that don't have any licensing requirements. All these states do, if you're doing tightness testing in these states, you absolutely do have to have manufacturer certification and training to do the testing. However, there is no state issued license that's required to be obtained by either taking a test or going to some continuing education in order to do work in these states. So with that, I'm going to move on to RP 1200 2019 version. First thing I'll talk about there is spill bucket testing. So Chapter 6 in RP 1200 covers both spill bucket and containment sump testing. Have a couple notes here. No matter what method that we're doing, I'm going to talk about the hydrostatic and vacuum testing methods. Spill bucket testing, you know, the buckets have to be visually inspected prior to testing, and that's in the preparation part of the procedures. And then also note number 2, and Russ covered very thoroughly, that owners can choose an industry code of practice, RP 1200, manufacturer's test procedures, or procedures approved by the authority having jurisdiction. First thing I'll talk about covers hydrostatic testing, 6.2. Very simple. You're filling up the spill bucket with water to within 1.5 inches of the top and looking for a drop in liquid level in the bucket. So RP 1200, you know, lays out these procedures step by step. Fill the bucket to within 1.5 inches of the top. Take an initial measurement of the liquid. I've seen testing done where they record the measurements from the top down to the water level. I think it's best done from the bottom up, gives an idea of how many inches of water the tester put in the bucket. So although it doesn't specify in RP 1200 which way you measure it, I think it's done from best measuring from the bottom up. You wait a minimum of an hour, take your final measurement of the liquid, and then as long as the liquid level does not drop 1/8 of an inch or more, the test passes. If liquid level drops 1/8 of an inch or greater, the test is considered a fail. Section 6.3 in 1200 covers vacuum testing. This would be vacuum testing single wall spill buckets or the primary bucket of a double wall bucket. Basically what you see here is a lid that's applied to the top of the spill bucket. You have a vacuum producing source, you have a valve, and basically a water column gauge that you attach. And the procedure is fairly simple. Seal off the bucket from the tank. You're going to pull 30 inches of water column vacuum. You wait 1 minute, and as long as your ending vacuum level is 26 inches or greater, the test is a pass. If your final vacuum level is under 26 inches of water column vacuum, spill bucket failed the test. And 6.4 in 1200 covers the vacuum testing of the interstitial space of a double-walled spill bucket. So another option for doing spill bucket testing, if it is a double-walled bucket, you can test the interstitial space. And to do that, again, you're going to attach your vacuum producing device and gauge to the interstitial space, as you see here in the picture out of 1200. You're going to pull 15 inches of water column vacuum instead of 30 inches of water column vacuum. You're going to wait 1 minute, and if your ending vacuum level is 12 inches of water column or greater, the test passes. Below 12 inches, the spill bucket failed the test. It's pretty cut and dry. All right, now I'm going to go into what's new in the 2019 version of RP 1200. First thing I'll mention, we have a couple new participants in the committee. Todd Darrow with Quick Trip Corporation, Bruce Garrett, Volta Oil, Ryan, and also Russ Brosick, who's on the call today, participated as well as a team. Russ did most of the heavy lifting, so I'm giving him some kudos there. And then we also have Brian Weigert of RNA Risk Professionals out of Iowa, who also joined the committee last year. So the new section that I'm going to talk about is section 6.6 for the low liquid level containment sump testing. So a couple things that I want to point out that the committee felt important to be in there, and I'll read them verbatim here. Low liquid level hydrostatic sump testing does not assess the integrity of the entire containment sump, but instead tests only the integrity of the lower portion of the containment sump and the ability of the liquid sensor or mechanical float device to shut down any submersible pump or dispensing devices associated with that sump. So it's important to understand that. Also, we felt very important to include the third bullet here. Under no circumstances should low liquid level hydrostatic sump testing protocol be employed for testing newly installed containment sumps for initial testing of containment sumps or for initial testing of containment sumps that have been repaired. So new containment sumps going into the ground and repaired sumps need to be tested with a high level test. Subsequent periodic testing can then be performed using low liquid level testing after that. So the requirements for a low liquid level containment sump test. The containment sump must have either A or B, and we're going to get into this in a little detail. A, it must have liquid sensors that are configured to shut down any submersible turbine pumps upon activation of the sensor, or the sump has to have standalone sensors that shut down a dispensing device or a mechanical float device that shuts down product at the float at the shear valve. If you are using option B, the facility has to be staffed when the dispensers are in operation. You can't use low liquid level containment sump testing at a facility that is not being staffed when the facility is in operation. So we're going to get into a little bit more detail here. So number 4 says basically you have to do a good visual inspection of the containment sump. And that's not just the bottom of the containment sump. That is the entire containment sump must pass a visual inspection. Test boots and secondary containment termination fittings must be present on the piping that penetrates the sump if the penetration will be within the liquid level of the test. We've had a number of questions about this. What if I don't have test boots, but they're 20 inches up in the sump? Well, you're not hydrostatically testing that part of the sump using a low liquid level containment sump test. So you don't necessarily have to have those on there if you're doing the low level test. However, if the piping is where the water is going to be during the low liquid level test, you're going to need to have those termination fittings on the pipings to eliminate the possibility of water getting into the secondary piping. And number 6 here is very important to understand. An electronic sensor or UDC mechanical float device must be installed in under dispenser containments and STP sumps. So the first bullet here says, if the sensor is electronic, determine if it's standalone or connected to an electronic monitoring system, such as an automatic tank gauge. So if that sensor is connected to an ATG system, that sensor is going to need to shut down all products associated with that sensor. So keep that in mind. Sensor goes to an ATG, that sensor needs to shut down all products associated with that STP sump or dispenser sump. If the sensor is a standalone dispenser, so it is not connected to an automatic tank gauging system, it's only connected to the dispenser. If it's an under dispenser containment sump, you're going to need to verify that it shuts down just that dispensing device. Okay. If the sensor is a mechanical float device, which is a float system attached to the shear valve arm, when that floats up, it's going to trip the shear valve, and it needs to shut down the shear valve, each shear valve in the under dispenser containment. So I think this is probably a place where we're going to have a lot of questions about it. But basically, I need everybody to understand that if the sensor is connected to the tank gauge, it must shut down all products associated with that sump. If it is not connected to the ATG, then that sensor just needs to either shut down the dispenser if it's a dispenser sump standalone sensor, or if it's a standalone sensor in an STP sump, then it would only have to shut down the appropriate STP sump. So once we determine that the sensor is set up properly, that it works properly according to the manufacturer's procedures for testing the sensor, then we move forward to doing the hydrostatic test of the sump. And to do that, we add water to the sump a minimum of 4 inches above the sensor activation point, typically 1 to 2 inches. And then to compensate for the sump deflection, we allow the water to settle for 15 minutes before we actually start our test. Pass-fail criteria. The containment sumps must pass both the sensor portion of the test and the hydrostatic portion of the test to be considered a pass for the low liquid level protocol. So, and that's basically what we say here. As long as the sensor's connected to an ATG and it sets off the ATG as required, and it shuts down all STPs that are associated with that sump, and the hydrostatic test passes, the containment sump would be a pass. Same thing if we had standalone sensors. As long as that standalone sensor that's connected to the dispenser or the STP, as long as that activates and shuts down as required, and the hydrostatic portion of the test passes, the test would be considered a pass. And then again, if there are mechanical float devices, if the test of the mechanical float devices passes and shuts down all the shear valves in the UDC, and that hydrostatic test passes, then the test can be considered a pass. Just like the high level portion of the test, the pass-fail criteria for the hydrostatic portion of the test is If the liquid level drops an 1/8 of an inch or greater, the hydrostatic portion of the test would be considered a fail. RP 1200 2019 version did come out with a standard form that can be used for low level liquid containment sump testing, and it's can be downloaded for free off the PEI website. So moving into repairs, and this will kind of segue into Roland and Tony's presentations. You know, we're going to have some repairs to deal with. I've provided a number of pictures here by several of our field technicians just within the past couple of weeks. So these are items that we're going to have to deal with, and just wanted to share some recent pictures of repairs that are needed to some of these containment sumps. Primarily when we see repairs needed, it's usually penetration fittings, as you can see here, that cause the problem. Most of the time, it's not the containment sump itself, it's these penetration fittings and secondary termination fittings that cause our guys heartaches, and repairs are needed to be done. I'll share some of these photos with you. And with that, my presentation is done, and I will take any questions now before we turn it over to Roland.
Great. Thanks so much, Ed. We have time for maybe 2 or 3 questions. Starting off, do states allow reciprocity if you are certified in another state?
That's a good question. To my knowledge, no. I've never seen states allow that if I was a certified tester in Pennsylvania, that I can be a certified tester in, let's say Ohio. I have seen it in regulation in other states. I believe Maryland has it in their regulations that you can apply for reciprocity, or maybe it's DC, but I've never seen it done or used.
Great. Next, how does RP 1200 treat high water table hydrostatic test requirements when the water table outside of the sump may already be 4 inches over the top of the highest pipe penetration or subseam?
Very good question. And to be honest, RP 1200 does not say anything about water table, unfortunately. And if that's something that you would like to see in RP 1200, I would strongly suggest that you go to PEI RP 1200 or pei.org/RP 1200 and make an official comment. And the next time that document is up for review, it can be discussed.
All right, you have time for one more. Low-level sump testing test warning. Did the committee consider inserting a warning that gravity will flow the leak to the lowest point and may overfill a sump to the low-level testing point and cause a release?
No, I don't believe that was discussed. With the low liquid level testing procedure, it does require that the sensor is in the proper position. It requires making sure that the sensor goes off and shuts down everything that it's supposed to shut down. So assuming that all is working properly, if the sump starts to become overfilled, warnings should go off by either those standalone sensors either shutting down the dispenser, causing the attendant to say, hey, what just happened to my dispenser? It just went down. Or the sensor should completely shut off all submersible pumps associated with that sump that's having the problem. And hopefully that would get the attention of the owner if they can't pump any fuel.
Great. Well, thank you so much, Ed, for the presentation and answering those questions. We will be transitioning to our next speaker, Roland Riegel. So let me just go ahead and convert over to Roland. 1 second. All right, Roland, you should be able to have control. Wait, hold on.
Right.
Sorry. Okay.
Right. Thanks, Nick, and good afternoon, everyone. Thanks to the NUIPIC organizers for inviting me to speak. And when they first approached me, the topic was more related to repair replacement sump compatibility. And I really thought, well, to understand that, you have to have a full knowledge of compatibility and what does that mean, and then in what type of application. Now, we've heard some presentations and regulations related more to, the inspection and maintenance portion, including repairing replacement of an existing sump. And UL 2447 does cover repair and replacement options. So there may be some crossover, but our standard focuses on more of the front end with the new product being installed. So just keep that in mind. And on your left are some of the topics that we'll cover during the discussion today. And then we will be focusing on repair and replacement parts. So the first real question is, what the heck is compatibility? And there's a lot of different definitions floating around related to the UST fueling systems. And those are evaluated under different protocols to which someone makes some type of compatibility claim against it. But if you think about it, it's ultimately up to the owner operator to accept whatever that risk of the claim and compatibility is, and you as regulators to approve it in accordance with your state or federal local regulations. So there's different interpretations, and again, this is where I'm trying to segregate. UL 2447 focuses on new sump products that are brand new from the factory versus some of the other topics that are discussed today, including KWA 823, which is more the inspection, maintenance, repair of the sump after it's been installed. So for the 2015 EPA UST regulations that were started enforcement back in 2018, I'm going to take some slides next from a presentation that I did with EPA last year, and these came from Ryan Hare's presentation on compatibility, and it again looks at the front end for the new products, where there's 3 compliance paths for compatibility. One is a listing of the product from a nationally recognized testing lab, which is UL or other NERDLs. A second is some original equipment manufacturer's written statement of compatibility. And then there's a third path, which is an alternative equivalent acceptable to the HJ, but I'm not sure if that's used. So again, these are 2 slides of those requirements and an example of, for example, on the left, one of the independent certifications that's UL, and another one is from a manufacturer to have that statement. So, but then it goes back to the question, what's the compatibility cover? Is it only the fuel? And if so, under what conditions? And do you have to consider other types of compatibility considerations that may also lead to leakage, which I think we want to ultimately prevent, which we're going to go through a lot more later through the presentation. So I'm not too familiar with, there's many different requirements out there, and what the technical basis on which maybe a manufacturer makes a claim or another standard is developed. but being in this business for 35 years and focusing on fuels and compatibility to it in my role since 2002, it's our opinion that 2447 has the highest level of independent testing to what I call real world requirements developed by technical experts backed by collaborative science. And this goes back to, if some of you remember, UL 971 underground piping back in the late 90s, early 2000s, lots of problems with leakage. And worked with a lot of your fellow regulators back then, like Laura Fisher Chaddock and Marshall Mott Smith, and a lot of others too. And we looked at it from an aspect of not only material compatibility, but system compatibility and individual components. So that's really the foundation upon which this and other UL standards are written. And we've spent millions of dollars doing research with national labs to come up with the proper test fuels. So while others look at only a material under a certain limited condition, UL has what we call a comprehensive evaluation philosophy to test all these combinations of an assembled product, which in a sump are a lot, to contain the fuel under really expected and unexpected conditions. That's what history has told us with the leak autopsy studies. Again, going back to the piping, it really wasn't just the pipe. It was the sump and the sump components that were failing that ultimately let the fuel get into the groundwater. So what we do is we look at the combination of sump components, how they're joined together, the pipes that connect in and out, the fuels, and how they progressed over time with higher levels of bioblends, and even their byproducts that cause a lot of the failures that we see. Chemical differences and a lot of the physical stresses that are not only from installation of the products and maybe repair later, but things like temperature differentials and maybe even ground shrink and settling. Okay, so keep in mind that I guess the key is that the individual material compatibility won't guarantee a leak type sump. It's really dependent on your weakest component in that system and how it was assembled and who did it. So what we do under our comprehensive evaluation is we first have the manufacturer identify what components that they want their product certified for and under which assembly instructions. So that could mean if you're a sump manufacturer, you would identify the certain through fittings, the type of pipe. And it also includes repair and replacement fittings. So a sump manufacturer could include in their certification evaluation of a repair means if it did get damaged during installation or after use. And then there's some repair replacement fittings out there. So those are included as well, along with a lot of other things that connect to the sump. Test monitor fittings, lids and covers, frames, and the chase pipe too, because that's all part of the containment. And how we ensure that this is going to be followed is through the certification that we offer. We have markings and instructions to use that proper assembly as validated by the testing, and that it has to be conducted by qualified persons. It's very key that a lot of these installations and repair replacement is very technical, has a lot of skill sets. You have to have the proper equipment and training. So how someone gets qualified to do it is very important. And we don't think that there's any other program out there that does these things other than UL 2447. So let's go back to probably what you're most concerned about is fuel compatibility. So back with that research that we did, decades ago, we've identified 4 fuel types to represent most of the common fuels dispensed out there today, from B0 to B20 and gasoline up to E85. What we call aggressive fuels replace the old ASTM reference fuels, because what we found in the research was that the compatibility was highly dependent upon what happened to the biofuel component with time, temperature, microbial attack. It broke down, created aggressive components like acids that decayed the products. So that's why we use the aggressives. And we have a technique called long-term thermal aging, which accelerates in time with higher temperatures. So for a primary containment, we do 90 days, and secondary, we do 60 days at 40 degrees Celsius. There's also fluids that are simulated with high acids, bases, salt, water, distilled, and also heat aging, because that's important too. So that's on the material side. And then in addition, we look at these combination of components. So it's both materials and the connection of the components. So for after these exposures, we do testing of the sump at minimum 5 psi with no leakage, and the materials themselves have to have a high 70% retention of their physical properties. So compatibility of the assembly, use, abuse, and environments are done prior to this long-term compatibility testing, because we use that to determine what is damaged, and any unacceptable damage to the manufacturer to take it out of service has to be simulated on a test sample. Why is that important? Well, think about a fiberglass sump that might get dropped, and you might have micro fractures, which could later lead on to failure. So that's what we simulate. We also look at high and low temperatures in the assembly and the repairs, because that's the real world. You've got workers out there doing it in hot and cold environments. You have materials with different properties that could create stresses. So it's very comprehensive, like I said, and this is what we do. So examples of use and abuse tests: we do drop impact before the assembly, and during that you do, for example, torque bending, pushing and pulling of the fittings, pipes and accessories per the instructions. And then you finally do, when it's all assembled and abused, you do the leakage test, and that simulates both on the external water load, soil load combinations, and internal leakage to contain the product. Test sample preparation is very key in the UL standards. I'm not going to go through everything, but a manufacturer could say, I want my product evaluated for a generic material, such as any FRP out there, or polyethylene, maybe a steel thickness, versus I only want it certified to a fitting manufacturer X, model Y, rating Z. Same thing for connection means. They can get into very, very generic information on, for example, resins, materials, pipe sizes, or something very specific, even for fittings, which have maybe a torque range, because if you under torque, you're going to leak. If you over torque, you might stress and crack a pipe. So these are very critical details that are in the assembly procedures. So, I'll give you some of the examples there with a focus on the repair and the replacement fittings. Surface preparation is really a key to that, along with other ones, to make sure things work properly. So the focus on the repair and replacement components that are allowed in the standard, what we do is we have to make sure that the effectiveness of the repair replacement is demonstrated on that system. And it has to be done per the instructions by a qualified person. And that includes the preparation, connection meetings, like we've seen in the other tests. The one important item is that we precondition some of these materials that are being connected to the fuels that I've mentioned for 10 days at 40 degrees Celsius. And why do we do that? Because that's the real world. If you repair in the field, you've seen conditions of sumps, and you have to make sure that the surface preparation addresses the proper bonding and sealing, especially when you have materials that absorb fuels, because that could compromise the integrity later on. I've included this slide to kind of give you a very high level view of the different ratings over the years of different UL products. And I circled the one for sumps and fittings and indicated that there's old ratings versus new ratings. And now we have the automotive ratings, which cover all of the biofuels. So for example, if you've got something in the B6 to B20 range, it's now covered by the UL standard 2447 with an automotive fuel rating, where the old standard, it wasn't covered at all. So you can use this chart not only for the sumps and fittings, but also some other common UST components like tanks and piping, and the differences that they have in the rating. So hopefully that's helpful for you as a tool. I want to talk about some, to wrap up, common misconceptions and cautions that, hey, any generic material is the same. And really what we found in our experience with testing is no, it is not generically the same. There's many different chemical differences. Like for fiberglass, you've got even different combinations of the fiber matte resin combination, percentages, the catalysts used. Bonding of polyethylene is extremely difficult. So either there's thermal bonding or heat application, which on a molecular level could be different for a high versus a low density polyethylene. Same thing with the capsulants and sealants in some of the repair replacement fittings, and also the tools and equipment. Some of the bonding, thermal forming, fusing apparatus, they're very different from one manufacturer to the other. Another misconception, similar components are interchangeable. Again, no. We've seen in the past, that's the history, that you can't have, let's say, a Franklin fitting automatically be compatible with another sump manufacturer. And the final one is, there's some manufacturers that say, well, we meet 2447, which is not the same as being UL listed, and you actually have to see the UL mark on the product, which you as regulators look for compliance. So that's another big item that's out there that you should be aware of. And to wrap it up before questions, some real final thoughts on the sump repairs. Again, we've tried to do our best to simulate expected use conditions, real world. And we do this in many different ways. When you look at the practical implementation of compatibility, given that wide range of products out there, you probably want to ask yourself, what's the age of the product? What are the ratings? What's the physical condition, degree of damage, the environments? All those are considerations when you look at whether something should be repaired or replaced. And finally, when 2447 was written in 2012, there weren't any new EPA regulations to have improved inspections. So it set a very high bar, given that, you know, we've seen these type of failures in the past and we wanted to try to prevent them. So between, you know, a good foundation with a product meeting a high level standard and the new regulations that you're implementing, that we're going to greatly reduce all these types of spill incidents. And with that, any questions?
Great. Thank you so much, Roland. I really appreciate that. So I'd like to give the opportunity for our audience to send some questions to Roland in the chat box, and please remember to address all questions. Roland, do you mind describing the parameters of a drop test?
Yes, the drop test is, I forget if it's a 3 or 4 foot. I think it depends if it's a sump component or the sump itself on a concrete surface. And then you visually examine the product for damage. And if the manufacturer says that that damage is acceptable, then you moved on to the next step. And ultimately, after all these tests, you're doing a leak test. What happens if you say, well, the manufacturer says it's unacceptable damage? They have to put that in the instructions that says that, hey, a hole in my product, if you drop it, you shouldn't put it into service. You know, it seems logical, but that's what we do.
Great. So it looks like that's, oh, got a few coming in right now. Are there lots of products under UL review at this time?
I'm taking UL review to mean in the testing phase, but not yet listed. I think there's 5 or 6 different manufacturers who have been listed, but there are many more who are currently under evaluation. We can't disclose who they are because it's proprietary, but the number of listings are growing. And there's the website that we have is always up to date.
All right, next we have, is there a spill bucket repair kit that has been tested? We talk about sump repair, nothing about spill bucket repair.
Yeah, well, sumps are you know, spill buckets are included in that standard. It's just one of the 4 different types of containment sumps. So you can have tank sumps, under dispenser sumps, transition sumps, and spill buckets covered by 2447. And yes, there are, I think, 2 manufacturers now that have got the listing for their repair kits on the fittings.
Great. And I think we'll have time for one more question. When testing a piece of manufacturer equipment, do we receive a batch or just one test?
I'm not sure the context of the question, so I'll try to assume the batch they mean a production run. So we look at first a lot of different products under maybe a family, a series and models. There's maybe different sizes of sumps, but they're relatively the same. We look at the worst case evaluation to determine the one that we actually test out of that series with a lot of different models. You know, like typically it's the largest sump in a design series because that has the highest, probability of failing due to the unsupported walls.
Mm-hmm. All right, actually, we've got one more. How long is a UL listing good for? Someone heard that they're only good for 1 year. Is that true?
No. Once the successful testing is done, the listing is good for as long as the manufacturer wants it and they don't change the fundamentally change the product. So that's part of the UL listing criteria, that where we do factory follow-up service testing to ensure that the products that were tested are representative of the production that goes out with the mark on it. If they change it, we can retest if necessary, but if they want it, it can keep on going for as long as they want.
All right. Well, thank you again for answering those questions. We will keep the webinar moving to Tony Reek, and let me just pass controls over. And Tony should be in control.
Yep, sure am. Hi, everyone. Pardon me. As the traffic cop directing the work on the NLPA KWA standard revision, I'm going to talk to you about NLPA KWA standard 823. Currently in a draft form, the predecessor document, which exists and has been adopted by a number of states, is NLPA KWA Recommended Practice 823. A recommended practice is more of a nuts and bolts type approach, and NLPA KWA 823, the recommended practice, provided specific information on how a fiberglass repair was to be performed and how in situ constructed sumps were to be built. When a different or better way of doing work becomes available, recommended practices are not equipped to adapt to the new methods. The NLPA KWA standard is in committee currently. It is in draft form. It is being developed as a performance standard, and we'll have a 60-day public commentary period, which should begin sometime early this summer, and I'll just keep that as a asterisk, that the asterisk means, well, assuming that we can resolve the last 12 issues that seem to be involved with it. So we hope to have the standard written in a way that allows new technologies to be used as they are developed. Reason that we're developing it into a standard is because the recommended practice was written before some very important changes in technology came about. Ich habe es dreimal geschnitten und es gibt jetzt zu kurz. What that means is I've cut it 3 times and it's still too short. Well, the tank owner's lament is similar. I've had it fixed 3 times and it's still broken. I can't tell you how often I've seen distrust in the tank owners for what was being told to them by contractors, and with good reason. I remember fueling my rental car at a station shortly after the first UST rules were published in 1988. Went into the store to pay, and I struck up a conversation with the owner. As we were speaking, a contractor pulls up, and the guy says, "I wonder what this guy's going to lie to me about." Companies are still lying to tank owners. I met an owner-operator that had tried 5 times to fix a failed sump. Each time the contractor had promised a solution, and each time the solution had failed. A standard provides methods which are proven and which can give credibility to the contractor. So here, you'll note that the before and after picture here is the same. Caulks, glues, even Flex Seal can't fix the problem. Standardizing the process, we hope will. Flex Seal may work really well sealing your gutters, or if you want to make a boat using a screen door, but it will not adhere to high density polyethylene, and it's not compatible with alcohol blended fuels as it's a rubber. So what are the goals of the NLPA KWA 823 standard? To provide information on the repairs available which do not require the expense or disruption of piping disconnection or breaking of the concrete. Fitting repair and replacement. Structural damage repair using structural adhesive bonders or patches. In situ construction of a new sump using the existing sump as a mold for fabrication. And watertight lid assemblies to keep water from entering through the top of the sump. To provide information on testing certification of devices and materials used to repair sumps. To assure appropriateness for the intended purpose. To assure compatibility with the product stored. To provide minimum testing criteria prior to returning a sump to service. Yes, a sump has to be tested before it goes back into service after it's been repaired. How do you do that? Well, obviously, we heard from Ed that it shouldn't be done with a low-level test. In the standard, the method referenced under the standard is a full hydrostatic test. And to allow for future innovations, which is an important caveat. Because when NLPA KWA recommended practice 823 was written, there was no such thing as a split repair boot. And here you see a couple pictures of a split repair boot. A recommended practice is a cookbook that doesn't offer any room to modify a recipe. And everybody knows that some things just taste better if you change if you change it around to fit your tastes. Well, split fittings and materials that could bond to HDPE didn't exist at the time of writing. And here's an example of use of a split repair fitting that shows how they are designed for a wide variety of applications. And it's a perfect example of the need to incorporate future innovations or be able to incorporate future innovations in the standard. Bonding to and repair of HDPE sump materials can now be reliably performed using chemical fusion bonding materials, which did not exist when the recommended practice was first published. I like to view a standard like a roadmap. It helps everybody get where they want or need to be. Maps used to be something one referred to prior to leaving on a trip in order to plan their route. Of course, maps have gone the way of the dinosaur and the telephone book, but using a map used to be that one could choose the most direct route or perhaps a scenic route to get to the destination. A standard provides direction and offers options for arriving at the desired result. Just like a map, the standard has to be followed from the outset. And here we have poor Bugs, and he's only now realizing that he should have turned left at Albuquerque because he didn't check his map first. Regulators need both strength and flexibility to be sure that rules are enforced and provide for viable options while maintaining a fair playing field. A standard also needs to be strong and flexible. Strong by providing clear direction and enforceable language. Flexible by allowing for future innovations. Flexibility also extends to contractors and owners, helping them find a solution that is right for the situation. Testing and certification. Testing and certification cannot be limited to large national testing organizations. Many smaller regional laboratories have the equipment and expertise to perform testing and certification of materials or devices for their intended use and compatibility. Under the underground storage tank regulations, a manufacturer uses a small laboratory or for conducting their tests where the laboratory does not meet the definition of a nationally recognized laboratory must supply a written attestation of compatibility. The standard requires the manufacturer to base the attestation on testing that has been performed by the smaller laboratory. In other words, we want to make sure that somebody just doesn't write a letter saying that they're compatible. We want them to base that letter on the actual testing that has been performed. NLPA Standard 823, testing and certification is limited to qualified independent laboratories in the standard. And that's simply because we don't believe that the size or the reach of a testing organization determines its ability to properly test a material for compatibility or for its intended use. And that the reach of the laboratory is much less important than the capabilities of the laboratory. Here we have NLPA KWA's table of contents and the scope, pretty much what I said before. 4 processes are described in the standard. Sump structural damage repair with applicable structural adhesive bonders or patches. Repair or replacement of sump entry and test fittings. Field constructing a retrofit single double wall sump utilizing the existing sump as a fabrication mold. Note, the process can also be used where there isn't an existing sump if it's allowed by the authority having jurisdiction under the standard. Repair, much like you have field erected above ground storage tanks, this would be a field erected sump. Repair or replacement of the sump lid assemblies to eliminate or prevent debris and surface water intrusion. And then we get to reference documents. And, these documents are listed, however, they're listed so that the user of the standard can find other useful information. The standard itself is standalone and does not rely upon any of the other documents. However, it does provide a listing of documents which may be of interest to the user from the American Petroleum Institute, the American Society for Testing and Materials, the Petroleum Equipment Institute, Underwriters Laboratories, the U.S. Environmental Protection Agency, U.S. Occupational Safety and Health Administration. So what else is in the standard? Well, NLPA KWA 823 has criteria for material approvals, which we discussed a little bit. Sump evaluation, what is irreparable sump, what isn't. Training and certification requirements for installers, and training and certification, as I believe Roland said, of installers ensures that the installer of a sump repair method meets both state requirements and repair manufacturer requirements necessary to properly complete the work. It's just important. General safety considerations, simply, there's no way to include every possible safety tidbit that possibly could occur, but we did our best to be able to address the major safety considerations within the standard. Information on the different types of sump fittings. I was surprised to find out, probably literally over 100 different types of sump fittings that are manufactured as repair fittings. Just to make sure that there's one for each type of sump, each type of connection, each type of thing going through that connection. Procedures applicable to the different repairs. In the procedures applicable to different repairs, the committee has been specific that repairs are not limited to manufacturer repairs. A lot of the sumps out there are from manufacturers that no longer exist. And so we wanted to be able to provide a document which addresses warranted repairs rather than warranty repairs. In other words, you have warranty repairs. Those are things that are done by the manufacturer in order to maintain the warranty of the device or the sump. And you have a repair which is warranted. In other words, it gives the owner some comfort level that the repair is actually going to last at least for a certain period of time. We also have repair, replacement, and new construction of sump lids. Most sump lids that came with sumps were not watertight. And to keep debris and water out of the sump when the water level rises temporarily is very important. Other materials of sump construction, well, we're addressing plastics for the most part in the standard, HDPE and fiberglass. But there are other materials that sumps are made of. I've seen a lot of the metal under dispenser sumps from Bravo, and there's also concrete sumps, which are sometimes referred to as vaults, which are very common in the communications industry. Here we have a 30-gallon container of water being poured over a sump lid just to make sure that water doesn't get to the inside. We are the only document that I know of that is trying to provide a method for testing a sump lid. You pour a large volume of water over the sump lid. Where possible, you would want to have the water actually submerge the lid. When it's not possible, you just keep pouring water over it for a specified period of time in order to make sure that water doesn't get to the interior of the sump. Here we have some examples of other sump or vault constructions. As I said, concrete is very common in the communications industry. And here we've got steel, and even a badly corroded steel or metal UDC sump can be made into a pretty and complete fiberglass sump because it makes a great mold still. The NLPA KWA Standard Committee is a balanced committee with representation from the regulatory community, the regulated community, sump repair system manufacturers, and contractors. A balanced approach to standards writing is exceedingly important. Regulators provide their point of view as watchdogs of the process. We have 3 regulators on the committee. Owners provide their perspective of real-world experiences with regard to the processes, site disruption, and the true costs of compliance. We have 3 tank owners on the committee. Manufacturers provide information on the products and processes available. Only they really know what their product can and cannot do, what it's been tested for. We have 4 repair system manufacturers on the committee, and 2 of those manufacturers also manufacture traditional sumps. And finally, contractors, because contractors have experience working with and installing the repair technologies. They know what works and what doesn't. We have 3 contracting companies represented on the committee. So in closing, I'd like to thank the committee members for their dedicated efforts as the standard is nearing completion. And I listed them, Joey Arn with Petroleum Containment Incorporated, Russ Broxick, who you heard from earlier, State of New York, US EPA assignment, Brian DeLegge with Tanknology, Olita Martin with 7-Eleven, Bill Hickman with the Colorado Division of Oil and Public Safety, Jeremy Templin with the Kroger Company, formerly with the Colorado Division of Oil and Public Safety. Alfred Reed, Broward County, Florida Environmental and Consumer Protection Division. He gets his own line simply because, well, it's such a long place that he comes from. John Seeger with Sheets Environmental Services. Scott Sharp with Armor Shield of America. Micah Nelson with S. Bravo Systems, another manufacturer of sumps. Paul Reber with Icon Containment Solutions. Jimmy Spiros with Neumeyer Equipment Company, and Ed Kubinski Jr. of Prompco, who we heard from earlier. And that should take me to questions and answers.
Great. Thanks so much, Tony. Appreciate the presentation. And we can start with a few questions. Reminder to the audience, please take this time to address any questions you would like to give Tony Reek. First, it seems like we would like to know what NLPA KWA stands for.
Well, NLPA is the National Leak Prevention Association, and they wrote a standard on tank lining, which was referenced under the original regulations as a means for compliance with the rule. There are several other standards that they put together, none of which have been so popular. KWA is Ken Wilcox Associates, and they're a testing laboratory. I think everybody in the regulatory community is pretty familiar with Ken Wilcox Associates. Ken passed away, I believe it was last year. No, actually it was the year before. And we'll miss him, but his son's quite capable of carrying on the family tradition. So yeah, that's what the NLPA and KWA stand for, and they got together simply because, well, KWA was writing certain standards, and then they had NLPA collaborate on the editing of second versions of several of their standards, and just it made a good fit.
Okay. So I'm not sure if this is a you or Roland question, but it came up during your section. Whereas UL and other testing companies are offering a guarantee of longevity of materials they test, what should be expected of material longevity, and is that addressed in the standard?
Well, I think that's more of a Roland question. From my perspective, I would simply state that warranties provided by the manufacturers of repair methodologies will give a minimum level of the length or lifetime to be expected from a repair fitting or a repair procedure.
Yeah,
you don't warrant something for 10 years if you don't believe that it's going to last 15.
This is Roland from UL. From our perspective, with the UL listing, the technical committee who put together the requirements and similar requirements for other fuel-containing products considers the expected life of the product and the accelerated aging program that we have reflects the difference. So like a longer term product like an underground fiberglass tank might have 180 or 270 day immersions, because the expectation is that it's going to be in the ground for 20 to 30 years versus a sump that is a little bit less. So that's why you have a reduction in the testing time. And another factor in that decision was, unlike a buried tank, a sump, you can have visual inspection, and you are required under the regulations to do so, which reduces the mitigation. But as Tony pointed out, a standard recommended practice or other document doesn't guarantee or warranty a product. The manufacturer does.
Okay. is there a minimum space, Tony? Is there a minimum space between? Sorry, is there a minimum space required between the sump lid and the sump walls for drainage?
Wow. Okay. In the standard that we're writing doesn't address the installation of sumps. Only existing sumps. It would be my opinion that the only reparable sumps would be those that were compliant. So that really isn't being addressed by the standard.
Okay. Well, looks like that is all we have for Tony right now. So definitely thank you for taking that time to answer those questions directly to you. Now it looks like we have about a little less than 15 minutes to go back and open up the questions for the complete panel. And one that we have here is for Russ. The federal definition, actually this was asked for everybody a little bit later on. The federal definition for a spill bucket is containment around the fill pipe and catches the small drips that occur in the delivery hose disconnected from the fill pipe. Are we requiring VR containment to be tested? Should we call this something other than spill bucket, considering the definition?
Well, yeah, that's probably a very great point. When people look at it in the field, it looks like a spill bucket, so they call it that just because, if it looks like a duck, quacks like a duck, walks like a duck, it must be a duck. But you're right, by definition, having this containment at a vapor recovery port does not meet the definition of a spill bucket. So it would be great to come up with some different terminology for it, but I think it's going to be difficult since it looks like a spill bucket.
Okay, great, thank you. And how familiar do testers/technicians need to be with state UST regulations? Are they required to get any operator trainings?
That's a great question as well. In the states that require licensing, in order to pass a test, in a number of states, you're going to need to educate yourself on the rules and regulations in order to pass the test and become licensed. So, in those states, it's really upon, the company and the individual to make sure that they are prepared, and understand the rules so that they can pass the test and become certified to do testing. In other states where there is no licensing and you only need manufacturers training on the equipment that you're using, regulations are not covered in those training classes. So oftentimes, no, there is no requirement for understanding the state regulations. I obviously think that that's an important part, and we try and educate our technicians on the rules and regs, where they're doing work, but globally, there is no requirement for that to be a tester.
All right, this one's for Russ or Ed. A standalone sensor in a UDC can shut down the dispenser. However, there is not a mention of an associated audible or visual alarm like in the EPA low-level guidance. This seems to be that PEI guidance is not as strict as EPA's. How do states allow use of PEI RP 1200 when EPA's guidance is more strict?
So I guess I'll start with that one. So that is part of the reason why, as we finished the process and we at EPA took a look at the two different procedures, said there are some differences between the two, and hence EPA left our low liquid level standard procedures up. But at the same time, within the regulations, something that has been adopted by a code of practice automatically becomes acceptable. So because EPA says that, and RP 1200 is a good standard. We recognize 1200 as being an acceptable process, even if there may be some differences like that that might otherwise not meet EPA's low liquid level process.
And again, I'd like to say, that if that's something, that is important, anyone can go and submit comments at any time on any PEI documents by going to their website, and the committee will look over the comments the next time the document comes up for review. Just so everybody knows, all PEI documents come up for review typically once every 5 years, unless PEI determines that a review needs or a change needs to happen earlier than that. So, and I'm not aware, me personally, I'm not aware of any standalone sensors that, have audible and visual alarms on top of shutting down that component that they are attached to. So, thinking of some under dispenser containment standalone sensors, they just shut the power down to the dispenser. I'm not aware that they might make audible and visual alarms as well.
Great. Another one for Russ. Is it common that NUI-Glide approved methods will generally be approved by EPA?
So I wanted to be really careful with that. And if you look back at my slides, there's 3 criteria that list out the alternative methods that EPA would find acceptable. The National Work Group is the ones that are reviewing that to verify that it meets those 3 criteria. So it's not necessarily saying, well, if NUI-Glide takes a look at it, therefore it's automatically accepted. It's saying that the criteria that EPA finds to be no less protective is what NUI-Glide is looking at before they list it. And if it meets those criteria, it's get listed, and therefore it's a demonstration that it meets the criteria that EPA laid out.
All right. Next, this is a general question. Do manufacturers allow plastic welding?
This is Ed, and we do repair work, and I know some of Cromco's repair guys are listening in on this webinar. I don't know that any of them would be comfortable doing standard welding, in a containment sump or under dispenser containment sump. I've never seen it or been aware of it. That's my only comment.
Well, having welded inside of tanks, I'm not that terribly shy about welding in an area where I have proper ventilation and proper monitoring going on, and I've eliminated the hazards demonstrably. But I think that was about plastic welding, and I believe that's the fusion systems where you have the different high density polyethylenes of the same thickness and same nature, and they're heated in order to become one, so to speak. And I don't know of anybody that does that in the field.
This is Roland. I've heard of some companies doing that with respect to 2447. You're permitted to do any technique, and we would just, again, look at how it's done with the equipment, the settings, and make sure that the 2 materials being joined along with maybe the strip of polyethylene are all compatible with the testing, because just like metallurgical welding, you can change the property of the material, which may compromise it. And that's basically why we do the testing.
All right. Next question for Ed. Why allow only dispenser shutdown for low-level testing? Does this assume that the CE operator will immediately investigate the dispenser sump to determine if the STP requires shutdown and not just bag the nozzle?
Well, we say in 1200 that, if it's, you're saying why allow the standalone sensors? The committee took that into consideration, and there are, many states have the requirement for secondary containment that goes back years, back into the 80s and the 90s, and a lot of these containment sumps and dispenser sumps that are out there, were never installed and intended to be tested, but now with the regulations, they're going to have to be tested. So, a number of individuals on the committee were very against low-level testing, but taking into consideration these older systems, the committee found it a good meeting place to, allow the standalone sensors when there was no connectivity to an automatic tank gauge to provide the positive shutdown to the submersible pumps. Because you talk to any of the owners that are either listening or on the committee, that's a huge expense to be able to, run conduit, put sensors, wire them for positive shutdown for everything. So, the committee thought it was a good meeting place, to allow that when you don't have sensors that can communicate to a tank gauge.
All right, and now we just have some general questions, so jump in whenever you feel like you can contribute. Are there any chase lines / rock guards used for flex piping, third-party rated for secondary containment?
This is Ed. I'm not familiar with, whether or not the chase pipes, rock guards are, compatible with the fuels.
Yeah, this is Roland. I'd have to look at the listings under 2447, but we did add chase pipe because it does form part of the compatibility or containment with the sump. But the certification would indicate that if it's for the chase pipe.
All right. Well, it looks like we have time for one more question. When using interstitial monitoring or double wall piping in UDCs, isn't it required that the jumper tubes to be removed, or at least the inner sides of the piping be opened under the UDCs?
Well, that's certainly an interesting one. I think that's going to get down to some site specifics. So if we look at that one diagram that I had where there was a jumper tube that connected the interstitial spaces of the two different piping runs, that's certainly allowable to allow the product to drain back to a monitoring point. The point of the monitoring of the UDC is for that single wall unit that's there, that's the jumper cables going around. That is considered part of the piping system as well. And so there is a need for monitoring of that UDC where there's that jumper tube where the single fitting is. But owners and operators may choose to have it open and monitor a section of pipe there, but it is not necessarily required by at least the EPA regulation.
Great. With that, we'd like to bring the webinar to a close. So I just want to say thank you to Russ, Ed, Roland, and Tony for taking the time to present. Stick around to answer questions on this important subject. This webinar will
Got
be
it.
posted on the NUIPIC Underground Storage Tanks webpage, where you can find multiple resources, including archived UST inspector training webinars, as well as Lust Corrective Action webinar series, and the complete archive of NUIPIC publication Lust Line. Again, take a moment to fill out your survey, which will be automatically opened in a prompt after you close the GoToWebinar window. You should receive a certification of attendance within the next 24 to 48 hours. I would like to thank everyone again for participating in today's webinar. I hope that you join us in future events. So thank you and have a great rest of the day.
Thank you, everyone.
Thanks.